Okay, so in this video, I'm going to be doing the review sheet for your test on circles, which is Unit 8. Alright, so to get started, on number 1, in order to find the measure of BD, of arc BD, that would be this arc right here, I see that this is congruent to this and that this is congruent to this. So therefore, I know that this whole segment here is congruent to this whole chord here. So if those chords are congruent, that means that this arc of the chord is congruent to this arc of the chord. And if I know that this arc here is 150, then I know that, so this whole arc here is 150, that means that my other arc is also 150 degrees. Okay? Number two, in circle O, angle 1 is congruent to angle 2. So this arc is congruent, or this angle is congruent to this angle. And angle 3 is 100 degrees. Therefore, I know that since this arc is 100 degrees, I have 80 left over for these two congruent. So if 80 is left over for each and they are congruent, this one's 40 and this one is also 40. So if both of those are 40 degrees, I know that arc RS, since it's the arc of this central angle, which is 40, I know that the arc is also 40. And then arc SRU is going to be this whole arc here, or this angle here, is a semicircle, so it's 180 degrees, and therefore the arc as well, which is a semicircle arc, is 180. So 40 plus 180 is going to give me 220. Number 3. For number 3, I know that since this is a diameter and this is a diameter, that this angle is a vertical angle to the other 45 degree angle. So therefore arc RS is also 45 degrees. TV is going to be the sum of this arc plus this arc. So therefore if this is 45 and this is 70, those two angles total 115. Therefore I'm left with an additional 65 to the 180, because all three of these should add up to 180 since it's a semicircle. So 65 plus 45 is 110 degrees. And then arc VS is going to be 180 degrees because VS is a semicircle. Okay, number 4, given circle M, AC is a diameter and angle A is 35 degrees. So if angle A is 35 degrees, which is right here, I need to find angle B. Well, I know that those are congruent because this and this and this are all radii of the same circle. So if this is congruent to this, this triangle is isosceles. And therefore, the opposite angles of the isosceles congruent sides are also congruent. So angle B is 35 degrees. And then angle CMB is 70 degrees. CMB, because if this is 35 and this is 35, I know that since this is a triangle, that the missing angle is 110. So if that's 110 degrees, these two angles here are a linear pair and therefore add up to 180. So 110 plus 70 would give me 180 degrees. All right, moving on. Number 5, in this circle, you know the measurements of KL, NO, and OP, and you know that this is a tangent. Well, you also know that this is a tangent here, so you know that this angle is a 90-degree angle. And you need to find the measure of KL, which is right here. If you notice, this is a right triangle. And since this is a right triangle, I need to find this radius of this whole circle right here. So in order to do that, I notice I have a secant and a tangent. So therefore, I'm going to use these two measures that I know. So I'm going to say the whole thing times the outside. So the whole thing is x. The outside is 2. So x times 2 is equal to the tangent squared. So 4 times 4 is 4 squared. So when I solve this, 2x is 16 and x is 8. Now that's the measure of the whole thing. So if the whole thing is 8, I need to take away 2, and I know that the diameter is equal to 6, which is the measure of IP. that means my radius is 3. And if my radius is 3, then I'm going to use Pythagorean theorem to find what the measure of KL is. Well, let's use a y, because we already used an x in this problem. So let's say that this is y. So I'm going to say y squared equals 3 squared plus 6 squared. So therefore, y squared equals 9 plus 36. So y squared equals 45. If I take the square root of both sides, I will get that y is root 45. To simplify root 45, I know I can multiply 9 times 5. So root 9 times root 5 is 3 root 5. So the measure of KL is equal to 3 root 5. Okay, number 6. Number 6 in this figure, in this circle right here, I know these following measurements. So ECD is an inscribed angle and therefore is half of its arc. So if this arc is 40, I know that this angle is 20. And then arc CE is going to be equal to this central angle. Well, this is an isosceles triangle again, so this is 20, and what's left over is 140. So if that central angle is 140, I know that the arc is also 140. And then BFD, again, is an inscribed angle, and the intercepted arc is 30, so therefore half of that is 15. And then CBD, if you notice, CBD is going to be 90 degrees because arc C or line CD is a semicircle. So that angle is an inscribed angle of a semicircle. So since the semicircle is 180, half of that is 90. All right, moving on to number 7. We want to find the measure of angle D. So therefore, I know that since that angle D is an angle outside, made up of an angle outside the circle, I know I'm going to take half the difference. So I'm going to take 8y minus y, and I'm going to divide it by 2. So that's what angle D is going to equal. The measure of angle D is going to equal that. Well, I need to find y. If you notice, I have all of the arcs of the circle, and what do all of the arcs of a circle add up to? That is correct. They add up to 360 degrees. So therefore, I have to solve this equation, which will give me 11y equals 360. Divide both sides by 11, and y is about 32.72 repeating. So we'll just say 727. And now I just plug that right into here, which is basically 7y over 2. So 7 times 32.727 divided by 2 is about 114.55. All right. Number 8, last one on the front. Quadrilateral ABCD fits perfectly inside a circle. So if I have a circle, so let's pull a circle out here, and I know that a quadrilateral fits perfectly inside of that circle. Just change the color here. So therefore, I know that I have something that looks like this. So I have a quadrilateral, and it fits right perfectly inside, meaning that it's inscribed. Okay, so here is A, B, C, and D. Okay, angle A is 70 degrees. Now, if a quadrilateral is inscribed in a circle, I know that opposite angles are supplementary, meaning they add up to 180. So if this angle and this angle adds up to 180, what is this one? It's 110. So angle C is equal to 110 degrees. Okay? If I wanted to find angle D, I could say that angle B was 90, and therefore angle D was also 90 degrees. But angle C is 110. Okay, I'm going to do the back in another video.